Hello everyone and welcome back. I am Mr. Cobalt and today we're going to talk about solution stoichiometry. And as we saw before, stoichiometry itself is where you have a balanced equation and you can use the mole ratios of the balanced equation to go from one substance to another. And so stoichiometry kind of relates to using that balanced equation and using those mole ratios to solve problems. So you need a balanced equation to use stoichiometry. This is called solution stoichiometry because now we're going to add to what we did before. So just to remind you guys of my chemistry superhighway here, the chemistry conversion superhighway. So this right here is the main highway that I have talked about. So in many problems in chemistry, you're going to be using this way of converting. So you're going to use molar mass a lot to convert between grams and moles, and you're going to be using mole ratios a lot to convert from moles of one thing to moles of another thing, and then molar mass. So if for the mass conversion, right, if I give you mass of one thing and I want, that's part of a balanced equation, and I want the mass of a different thing, then you would start here, convert to moles using molar mass, and then use the mole ratio in the balanced equation to convert moles to moles, and then moles of the substance to grams using the molar mass of that substance. Now with solution chemistry, you're not going to be given grams. Most likely you're going to be given a volume and you're going to be given a molarity. And so in every problem, you're going to want to get onto the highway somehow. So if you're given a volume of a solution, and the volume could be milliliters, it could be liters, whatever they give you, your way back onto the highway is through the molarity, because we saw before that you can use molarity as a conversion factor. Okay, so if you don't have liters, then you need to convert milliliters to liters, and then you can use molarity as a conversion to get to moles, and then once you're here, then you can convert using the mole ratio. And then if there's asking you for a volume of the whatever product or other reactant, then you're going to have to get back off. So if you got moles of your other substance, then if they're asking for a volume, then you need to use the molarity of that substance to get back on off the main highway and to get to your destination here, which is the volume of another solution, right? So that involves solution stoichiometry. So we're adding roads to our main highway. So how do we do a problem like this? So this is the first problem I'm going to go over. So the problem says, what volume in liters of a 0.150 molar KCl solution will completely, and that's a key word, completely react with 0.150 liters of a 0.175 molar PbNO32 or lead to nitrate solution according to the following balanced equation. So here's the balanced equation that they're giving us. So you'll notice right away that they are giving us information for two of the reactants. So they're giving us for the lead to nitrate, they're giving us a volume and they're giving us a molarity for this reactant. And they're giving us a molarity, they're giving us a molarity for this reactant, but not a volume. So we want to find the volume. So in this case, you're going to start with the information they give you. And so anything that's a molarity, you're not going to start with because that's used as a conversion factor. And 99 times out of 100, you're not going to start with a conversion factor. So they want to find volume of KCl when you're given molarity. So we need to get to liters of KCl. They give us two molarities, so molarity of lead to nitrate and they give us the molarity of KCl. So we're not going to use those. Those are going to be conversion factors. So the only other thing they give us is liters of lead to nitrate. So we got to start there. So let's start with the liters. So we're going to start with 0.150 liters of the KCl solution, and we're going to put that over 1. So now we have liters of solutions, but we need to convert, and we need to get onto our highway. So if our A is our KCl, we need to get onto the highway. So to get to moles from liters, that the relationship between moles of solute KCl to liters of solution is molarity. So we can use molarity to convert to moles. So they give us the molarity of the KCl, right? Or I'm sorry, the not KCl. We want, this is the PB. Oops, already started a mistake. So that's going to be liters of the lead to nitrate. I wrote the wrong thing down. So PB nitrate NO3 So there it is. And so we need to use the molarity of the lead to nitrate. So this is going to be read as 0.175 moles per liter. So we translate that into 0.175 moles of the PB NO3 the lead to nitrate, and that's going to be equal to 1 liter of the PB NO3 solution. Okay, so these two are equal. So we're going to put the liters on the bottom since we have liters on top. So 1 liter of PB NO3 solution on the bottom, and then we have 0.175 moles of the solute, which is our lead to nitrate. Okay, so lead to nitrate solution, the liters cancel out, and now I have moles. Now I have moles of the lead to nitrate. So lead to nitrate, here we go. So now I have moles of my A, and now to go from moles of the lead to nitrate to moles of my KCl, I need to use the mole ratio. So now I'm following my roadmap. So I'm now going to use the mole ratio between KCl and lead nitrate. So it's a 1:2. So I'm going to do my conversion. So here we have, moles of lead to nitrate on the top. So I'm going to put 1 mole of the lead to nitrate on the bottom, and then 2 moles of the KCl on top. So moles of the lead to nitrate cancel out. Now I have moles of KCl on the top. What do we want? We don't want moles of KCl, but we want volume in liters of the KCl solution. So to go from moles to liters of solution, I'm now going to use my molar mass, my molarity as a conversion factor. So they gave me the molarity of the KCl solution. So here, this is 0.150 molar, which means that I have 0.150 moles of the KCl in 1 liter of the KCl solution. Okay, so I can use that as a conversion. So I have moles of KCl on top, so the 0.150 moles of KCl goes on the bottom to cancel out, and the 1 liter of KCl solution goes on the top. So now moles of KCl cancel out. I have my liters of KCl solution. So now all I need to do is calculate. So, as you can see here, I started with the volume. I used molarity to convert from volume to moles. And then I used the mole ratio to convert from moles of A to moles of B. So I went from lead to nitrate to potassium chloride. And then finally I'm using the molarity of my potassium chloride to go from moles to liters. So let's calculate this out. So I have 0.150 times 0.175 times 2, and then I have a 1, so now I'm going to start to divide. Divided by, what's on the bottom? I have 1, 1, 1, and point 150 equals, and I get 0.35. So this becomes 0.35 liters. Liters of what? My KCl solution. So, let's check our sig figs here. So, my mole ratio here isn't exact, so I can ignore that. Here, this is a measure, 0.15. That's my molarity, so that's 3 sig figs. Here's molarity, that's 3 sig figs, and then that's 3 sig figs for the volume. So I should have 3 sig figs here, so I need to add a 0 at the end. So that is the amount of volume that I need of my solution, my KCl solution, my 0.150 KCl solution, that is going to react completely with my volume and molarity of the lead nitrate solution. So the great thing about the word completely is that this is not a limiting reagent problem. Because it says completely, one reactant is going to react completely with the other, so that at the end of the reaction, both reactants are gone. I don't have any leftover reactant. So that tells me when they use this verbiage, like completely, that tells me it's not a limiting reagent problem, and I don't need to find what the limiting reagent is. Now, however, I'll say this right now, before finishing up the video. This could have been a limiting reagent problem, right? So they didn't have to use the word completely. They could have just given me a volume and a molarity, and then they could have given me a volume and molarity for my second reactant and said, here are the volume and molarities of the 2 reactants, how much product is formed. And so in that case, I would have to figure out which one is the limiting reagent, and I would have to go through the steps of going from, say, the volume and the molarity of my 2 reactants, and then go through the process of getting to moles or mass of my product for each reactant, and then seeing which one gives me the lower amount of product. But we didn't have to worry about that because of the fact that we're being told that it's reacting completely. So we don't have to worry about that. And so we got the answer. So this volume of this molarity solution of KCl will react completely with this molarity and volume of your lead 2 nitrate. I hope that's helpful. If you enjoyed this video, please like the video. Please share it with your friends. Please subscribe to the channel. Make a comment in the comment section, and hit the notification bell so you can be notified when I put out any other videos. Thanks for joining me, and see you next time.